Morning students. So today we'll discuss about the modern period table. In that the classification of these elements into the groups, right? So last class we have been discussing about the classification of elements into periods. So there have been the 7 periods, right? So now we'll move on to the groups. So in that the people already know. So the group 1 elements. So that is nothing but the lithium in terms of the sodium, potassium, the rubidium, cesium, and then the francium. They are called the group 1 elements, right? So the group 1 elements we are called an alkali metals. Group 1 elements we are called an alkali metal. It will become for group 2 element. So that is in terms of here the beryllium. So we go for the magnesium, the calcium, the strontium, the barium, and then the radium. They are called the group 2 elements. They are called alkaline earth metal. So this one we are called an alkali metal. So that is an alkali metal, and this one we are called an alkali earth metals. Alkali earth metals. Right. So we should know why these elements we are called alkali metal and these elements are called alkaline earth metals. Right. So for example, this lithium when it is dissolved in water, it will be your respective hydroxide. That is lithium hydroxide. If it will be dissolved this one, this is sodium hydroxide. So this potassium has been dissolved in water, it will be your respective potassium hydroxide, rubidium hydroxide, cesium hydroxide. Understood? Right. So these hydroxides are basic in nature. Basic is nothing but the pH is above 7 and between 14. Between 7 to the 14. Right. So if we go for beryllium, the same thing, beryllium hydroxide, magnesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. It will be your respective hydroxides. Because of this respective hydroxides, they are basic in nature. This basic nature we are called alkali. The basic nature we are called alkali. Right. So that's why they are called alkali metals. These are all metals and they are basic in nature. They are called alkali metal. So these are alkaline earth metals. They are available in the earth crust. That's why they are called alkaline, basic in nature, alkaline earth metals. Right. So if we go for the group 16 elements, the group 16 elements we are called chalcogens. Right. So that belongs to oxygen family. That is in chalcogens. Right. That is belongs to an oxygen family. Chalcogens are here. Right. So they are ore forming capacity. They have been ore forming capacity. Right. So they have been combined with some respective metals and the formation of ore, ferrous oxide. That is a hematite ore. Right. So in terms of here, if we go for aluminium oxide, alumina, bauxite ore. Right. So cuprous oxide, zinc oxide, they are ore forming capacities. That's why. So they are called chalcogens. And the group 17 elements we are called halogens. Group 17 elements we are called halogens. They are salt forming capacity. So group 17 elements are nothing but, so that is the fluorine, bromine, iodine. So they are all halogens. Fluorine, bromine, iodine, they are all halogens. They are salt forming capacity. So when these elements, it will be combined with respect to electropositive elements or alkali metal, it will be form the salt, sodium chloride, potassium chloride. Right. So these halogens, they are being in terms of they are nothing but the salt forming capacities. Right. So come for group 18. The group 18 elements are nothing but they are noble gases. They are noble gases. They are noble gases. It's also been called in terms of rare gases. Right. Stable. They have been stable, completely filled orbital. So that is nothing but in terms of here. So the helium, neon, and argon, krypton, xenon, and then radon. They are nothing but in terms of here. So the noble gases, rare gases. Right. So these have been nothing but in terms of here. The elements has been they have been the groups. Right. So this group 1 elements were called alkali metal. The group 2 elements were called alkaline earth metal. The group 16 elements were called chalcogens, and group 70 elements were called halogens, and the group 18 elements were called the noble gases. The gases. Right. So in terms of here, just we'll discuss how these in terms of here the elements have been classified into the blocks. So this in modern periodic table they have been classified into the 4 important blocks. Right. So S block, P block, D block, and F block. Right. So we have been called S, P, D, F. Right. So that is S, P, D, and F. Right. S block, P block, D block, and then F block. They have been classified into the 4 different blocks. Right. So 4 different blocks. We'll discuss one by one. We'll go for the first one. So that is nothing but an S block element. Right. S block element. So this one it will separate one chapter itself. It is there. So you'll study about in detail about S block elements. Right. So already we people have know the group 1 elements and group 2 elements belongs to S block. Right. So that is in terms of here the lithium, and in terms of here the sodium, the potassium, rubidium, cesium, and then the francium. Right. So that is belongs to group 1, and if you come for group 2 so that is in terms of here the beryllium, the magnesium, the calcium, strontium, barium, and then the radium. That is belongs to group 2 element. So this both element, the group 1 and the group 2 belongs to S block element. Right. So why these element belongs to S block? That's been very important. Right. So because the differentiating electron, that is nothing but the last electron has been entered into the S subshell, S orbital. Right. The last electron is entered into the S subshell or S orbital. That's why. So these elements are placed in S block element. For example, if we go for electronic configuration of lithium, right? So lithium anta barta hai. So if we go for electronic configuration of lithium, there is 1s2, 2s1, right? The last electron is entered into the S orbital. So if we go for sodium, that is an 1s2, 2s2, and 2p6 and 3s1. The last electron is entered into the S subshell, right? So if we go for beryllium, right? So beryllium, that is an 1s2, 2s2. Again, the last electron is entered into the S orbital. Right. So if we go for calcium, right. So if we take the calcium atomic number is 20. Atomic number is 20. So electron configuration, that is an argon. So we got a short different. So argon, the 4s2. Again, the differentiating electron has been entered into the S subshell. Right. So that's why. So these elements they have been. You can write any element. You can write any element. So the last electron get entered into the S subshell. Right. So that's why. So these elements they have been placed in S block elements. They have been placed in S block elements. Right. So this group 1 elements we are already told they are called alkali metals. They are metals, alkali metals. Right. So the group 2 elements are called alkaline earth metals. Alkaline earth metal. If we go for general electronic configuration, right? So general electronic configuration of S blocks are nothing but, so that is an NS2. 1 to 2, right? NS 1 to 2, where N is nothing but the principal quantum number. Where N is nothing but the principal quantum number, where minimum it has been filled in 1 electron. And maximum it has been filled 2 electrons. That's why 1 to 2. Right. So if we go for an alkali metal, so it has been filled only 1 electron, NS1. Right. So if we go for alkaline earth metal, the 2 electron get filled. So that's why NS1 to 2. That is the general electronic configuration of S block elements. Right. So it will be containing only the 2 groups. It will be containing only the 2 groups, the group 1 elements and group 2 elements. Right. So these elements are highly electropositive elements. Right. That's been very, very important. So that's the first point. Come for second point. They are highly electropositive. They are highly electropositive. Electropositive means they have been the tendency to lose electron. They have the tendency to lose electron. For example, lithium atomic number is 3. Right. They have been the tendency to lose 1 electron. right? To become stable, it will acquire the configuration of helium, right? So if it become for sodium, atomic number is 11. It will be eager to lose electron to acquire the configuration of neon, right? So atomic number of potassium is 19, right? So the nearest configuration of noble gas is argon. How much? 18. So it will be tendency to lose one electron, right? So that's why the valency of alkali metals are 1. The valency of alkali metals are 1. Valency for alkali metal is 1. Remember, right? So if you become for alkaline earth metal, the beryllium, that is atomic number 4, right? Nearest noble gas is helium. It will be lose 2 electrons to acquire the configuration of helium. That's why it will be lose 2 electron, beryllium. If you become for magnesium, atomic number is 12. Magnesium atomic number is 12. Nearest to noble gas, which one? That is neon. So atomic number is 10, neon, right? So it will be lose again 2 electron. Here also 2 calcium is 2 electron, lose 2 electron. So that's why the valency of alkali earth metal is 2. That's why they are called electropositive element. They have the tendency to lose electron. They have the tendency to lose electron, right? So alkali metal, it will be lose 1 electron. That's why valency is 1. The alkaline earth metal, it will lose 2 electron. The valency is 2. They are electropositive element and they are highly reactive elements. They are highly reactive elements, right? So that's why the sodium that has been stored in kerosene, right? So why it has been stored in kerosene? Because that will be reacts with atmospheric oxygen or atmospheric moisture and that will be catches fire. That's why they have been stored under the kerosene, right? So in terms of here come for the third one okay? So they form ionic bond. They form ionic bond, right? So such a type of the S block elements, they will form ionic bond, right? Ionic compound. So for example in Na plus and Cl minus, sodium chloride, right? So that we will study in detail about some other chapter, right? Ionic bond. So that is K plus and NO3 minus, potassium nitrate. Na plus and Cl minus, potassium, sodium chloride and potassium nitrate. They form an ionic compounds or ionic bond, right? So it will form only ionic bond only. So that is belongs to an S block. The general electronic configuration of S block is nothing but so NS 1 to 2. So where group 1 and group 2 belongs to S block. The group 1 and group 2 belongs to an S block, right? They are highly electropositive element. Electropositive means there is formation of positive charge. How will get the positive charge? By losing the electrons. By losing the electrons, right? Come for next one. So that is we'll go for more to the next one. That is nothing but so the P block elements, right? S block. We'll go to the second one. That is P block. We'll go for second one. This is the first one. Come for the second one. That is an P block element. If I come for P block, right? So if I come for P block, this P block, the differentiating electron that has been entered into the P orbital. The last electron is entered into the P orbital. That's why. So these elements they have been placed in the P block. That's why these elements are placed in the D block P block elements. For example, I'll give an example. So there is a nitrogen, right? Nitrogen atomic number is 7. If I go for electronic configuration, 1s2, 2s2, and 2p3. Right. So 1s2, 2s2, and 2p, the 3. Atomic number is 7. 2 plus 2, 4, 4 plus 3, 7. The last electron agide, so p orbital entry agide. Understood? So if we go for, we will take the one more example, that is the phosphorus. So we take the phosphorus, 1s2, 2s2, and 2p6, 3s2, and 3p3, 3p3. Right, atomic number is 15. Again, the last electron has been filled in the p orbital. So that's why. So the few elements have been placed in the P block elements because the differentiating electron, the last electron that has been entered into the P orbital, right? P orbital. So in terms of here, that one we are called the P block element. If we go for general electron configuration for P block, the general electron configuration for P block is nothing but an NS2 and NP1 to 6. NS2 NP 1 to 6, Right. So this is NS2 s orbital. It will be capacity of s orbital is 2 electron. It is already filled. If it become for P, so the minimum 1 electron, the maximum 6 electron. That is NP1 to 6. NP1 to 6. Right. So here the groups are nothing but group 13 to group 18. The group 13 to group 18 belongs to P block element. It starts from group 13 and ends with the group 18. That is belongs to the P block elements. Right. So we people already know the group 18 elements. They are called noble gases. That is helium, neon, argon, krypton, xenon, radon. These are all noble gas. They are called rare gas. They are completely filled orbitals. They are stable. They are least reactive. They are least reactive. That will be not react easily. Right. That's why they are called least reactive. And group 17 elements they are called halogens. Group 16 elements they are called chalcogens. Understood? Right. So in terms of here, if we go for here, the most of the elements are non-metals. Right. So most of the elements, few also be metals have been also been present and metalloids also been present, but most of the elements. Right. So most of the elements that is belongs to P block are non-metals. They are all non-metals. If it come for here it will be form both ionic compound and covalent compound. And a covalent compound. How they will form ionic compound? How they will form covalent compound? That's very important. Ionic compound, if it will be lose complete electron completely. Right. If it will be an element or an atom that will be lose the electron completely. Right. So they are nothing but in terms of an ionic compound. If an atom that will be share the electrons, right? If it will be atom that will be share the electrons with the neighboring atom, and there is the formation of a bond. That one we are called covalent bond. Understood? Right. So this is about your the P block element. Right. So general electron configuration of P block is nothing but NS2 NP 1 to 6. The groups are nothing but group 13 to group 18 belongs to P block. Right. So they will form ionic bond as well as the covalent bond, covalent compounds. Right. So come for next one. So that is nothing but in terms of here. So the D block elements. D block elements. D block elements. So this S block and P block people will study in first year only. Right. S block and P block that will be studied in first year only. So in second year you will study all the three. Again you will study about few groups of P block and whole D block and F block in detail. Right. So in detail you will study. So come for D block elements. D block elements बता के रखता है. The differentiating electron has been entered into the D orbital. Right. So that's why they are called D block elements. Right. The differentiating electron means the last electron they have been entered into the D orbital. Right. So they are called the D block elements. If we go for here in terms of here, so the group 3 to group 12 belongs to D block. Group 3 to group 12 belongs to D block. Right. So that is the D block is present between the S block and P block. They have been placed between the S block and P block. Right. So S block is ends with the 2. Right. Again it will start from the 3. Right. So it has been this D is ends with the 12, and again after that it will start with the P, group 13 to group 18. Right. So come for general electronic configuration of this D block. So that is an n minus 1 D 1 to 10 and NS 1 to 2. That is belongs to D block. Right. So this is the general electronic configuration of the D block elements. Remember that this will be very important. You will ask for competitive exams. Right. You will ask for the competitive exams. So that is n minus 1 D 1 to 10. Minimum 1 electron, maximum 10 electrons. The minimum is 1 electron, maximum is 10 electrons. Right. Just why I wrote n minus 1 here? Why I wrote n minus 1? This will be very important. Right. Why I wrote n minus 1 means just assume these are all orbitals. Right. These are orbitals. This orbital, again orbital, there have been like orbitals have been present, right? So assume this is the outermost shell, right? This is the outermost orbital. This is the outermost orbital. But last electron that has been filled in this orbital. Okay, the last electron has to be filled in this orbital. But illénagutte anta helidaga, so last electron ille entry aginagutte, it has been entered into the inner shell. Last electron inner shell entry agutte. Ille entry agalla. Ille fill agutte. That is the 4s. After the filling of 4s, it has been filled in the 3D. Right? So one layer ginta ಒಳಗಡೆ last orbital ginta in ಒಂದು ಒಳಗಡೆ ಏನಾಗುತ್ತೆ electron fill ಆಗುತ್ತೆ. So that's why in terms of here, so that's why we have to be right n minus 1 d minimum 1 electron, maximum 10 electrons, and ns 1 to 2. This is the general electronic configuration, right? So this d block elements almost all metals. This d block elements almost all metals. Titanium, vanadium, chromium, manganese, iron, cobalt, copper, nickel, zinc, right? So platinum, gold, mercury, almost all metals. These are all metals. This d block element is also called transition element. Transition means intermediate, right? So because they have been placed between the d and they have been placed between the s and p. They have been placed between the s and p. That's why they are called transition. For example, you people are PU, right? So you people are intermediate and intermediate PU, we are called intermediate because they are neither high school, they are neither belongs to high school, neither belongs to degree. They are intermediate, like that only. So the D also been called transition or intermediate compounds. Transition means intermediate because they have been placed between the s orbital and then p orbitals, right? So they are called transition elements. They are called transition elements. They are called transition elements, right? And most of these d block elements are metals. Most of these d block elements are the metals, right? So one more important thing is nothing but they will form in terms of here the covalent bond, right? So they will form ionic bond, ionic as well as in terms of here. So the coordinate bond, coordination compound, right? So maximum they will form coordination compounds. Maximum they will form the coordination that will be studied in detail, right? In particular exact chapter there, right? So particular future chapter there. So in detail work they will form both ionic and also the coordination compound. So these elements exhibit the colors, right? So they have been different colors. So chemistry is also in colorful subjects. Right. So why the chemistry is colorful subject? Because these metal atoms that will exhibit the different colors because of the transition of electrons from lower energy to higher energy. That will be studied in detail about in second PU. Understood? We come for the last block. So that is nothing but F block elements, the fourth one. Right. F block.